Hello, my name is Rod Kowicki. I'm an author, I'm a researcher. I've been researching physics, space travel, the theories, uh, and I've come up with a new 25th century, or actually 20th century, but 2025 theory. My latest book is called EVG, Expanse Vacuum Gravity. What's it talk about? It talks about the speed of light, relativity. See, it was Einstein that put a spacecraft and velocity in physics. Um, he, the conclusion of his ideas were the universal speed limit, the speed of light. He conformed a theory that our universe was in a bubble. And in that bubble, everything is limited to the speed of light. I mean, that's the speed limit. I mean, you go 50 miles an hour, 100. But he did not take the perimeters in his theory to where they actually are. In other words, if you go 100 miles an hour on Earth, in space you go 200 miles an hour. Why? Because there's no attraction force. Uh, Accordingly, even E equals mc squared, everything is made up of some sort of nano energy, but it has the same distinctions as electricity, like quantum computers, electricity, communication skills over the phone can travel as fast as the speed of light with no interference. In relativity, uh, energy is interference. The external point or perimeter aside from the object uh, or spacecraft, let's say. Uh, Energy can actually push or attract a moving ship in space or on Earth or on a planet that has gravity. Uh, but like I said, a ship that, or even a car that travels 100 miles an hour, weighed on its propulsion value, um, and travels 100 miles an hour in space, if a car could travel in space like a ship, it's 200. He never put those perimeters together. He said they're both the same. Uh, we're in a bubble, and that's it. Well, in 1925, Erwin Hubble uh, was doing research through the telescope, discovered that galaxies were actually being pushed apart from each other in uniform volume. In other words, their expansion uniformity is consistent to even today, even from the beginning of the universe. They say the universe is expanding and accelerating. I think that the acceleration was more when it was a younger universe, and now it's actually slowing down. Um, See, the parameters for space expansion are uh, a, a space anomaly, a sphere that, like a beehive, all the bees are running, are flying around this beehive. Well, the beehive is the sphere, and the bees are the galaxies. But they travel in uniformity. They're consistent from whatever they do in a beehive. In space, the galaxies are in uniform, but the universe is expanding. The space between them is getting greater at about 43 miles a second. Now, that may not sound much, but for a universe to have such energy, uh, repulsive energy, it has to be greater than the speed of light. It is greater than the speed of light. Hubble theory uh, debunks relativity, and relativity is based on the speed of light. So we have a problem with equations and consistency, parameters, and conclusions in relativity. So 43 miles a second isn't much, but how much force would that be relative to the speed of light? We have the speed of light. Okay. Uh, 186,000 miles a second. To take the 43 miles a second expanse force, we have to change it into energy and velocity. So, uh, to do that, we have the speed of light, which is formally, well, it's relativity's parameters for and a speed limit. If the universe is expanding and there's a force that is doing it, rather lethal force, push force, repulsive force, volume uh, acceleration, uh, we have to weigh it with the speed of light. So I went back and looked at the mathematics of how energy works and acceleration, momentum, and I discovered that for a 1 pound object to move, it takes 2 pounds of that product energy. So if it weighs 1 pound, another 1 pound will not. It won't do nothing. It won't move it. It takes at least 2 pounds of energy. So in relativity, it's 1 pound, but it's limited to the speed of light and it doesn't change. So that's one. To make momentum or mobility within the universe related to energy, we need 2 pounds. 2 pounds is 372,000 miles a second, twice the speed of light. Something greater than the speed limit, which is in relativity to the speed of light. So we have 372,000 miles a second. Then we have what might be called the material energy. Whatever the energy is made of is a conformity that is making that energy. In other words, if you have a battery, let's say, and it puts out so much energy that you have to have the battery is the source. The wire is the volume of energy that grounds the acceleration or momentum and changes it into mobility. So, so we have 372,000 miles a second, which is twice the speed of light, and we have more, a little bit more, for the solidity of this force. That comes out to approximately 450,000 miles a second. We change that velocity into energy by squaring it. So 450,000 miles a second times 450,000 miles a second, and that's how much energy, and that's a lot of energy. That's almost 3 times the source of relativity. And where does this source come from? It comes from the expansion of the Hubble sphere, which is the force that's creating the parameters for the repulsive force or expansion force or EVG, expansion vacuum gravity. So, in all, we have a space environment that is growing, getting bigger, and it's spreading the galaxies apart. This is the quantum physics theory. I've written over 15 books, but I'm not famous. Unlike Einstein, who created relativity in 1915, he also helped formulate the equations for the atom bomb that Germany was working at the time. So that was his scientific background. His scientific discoveries came when came to the United States and worked as a patent clerk, where he observed patents for scientific or physics theology or theoretical physics and experiments. That's where he got his knowledge from. And he wrote a couple of books. The first book, Special Relativity, was about 100 pages. And the second book was General Relativity. It was about 125 pages. Those two small books uh, changed science as we know it. Later, he wrote 5 papers explaining the anomaly of the experiments that were involved in relativity. So, the experiments involved that proved relativity were by other people, and this was his observation on them. And But it's not the basic science you see in colleges and universities. It's a aptitude of science as a whole. Um, my ideas came from the perimeters of uh, relativity, uh, the speed of light. But his mistakes debunks, as you might say, relative to the speed of light constant, which is not constant. It's constant to light, but it's not constant to our universe or space as we know it. There's a big difference between the two. Yeah. So he has this bubble we're in. The Hubble sphere uh, theory. The galaxies sit outside the bubble. The planets, stars, suns, and everything that make up the galaxies. Those are entities inside that make up the galaxy and are inside it. And we have a billion galaxies. They surround this cocoon or sphere like the beehive. Uh, so basically, that's what my books are based on. I try to give explanations like I did about here about energy and how we use energy to perimeterize acceleration. See, but acceleration is how fast you're going. And in space, once you hit that point of acceleration, you don't need the engines no more. You'll just keep going. But there is the problem of another ship you might run into, but as big as everything is, I don't think so. That's the kind of problems you would have, like traffic, street traffic on the highway and stuff, bumping into something that's not in its particular realm or where it's supposed to be. That's kind of like what space is we have no travelers. We are the travelers. It's weird to think if we are the travelers and we have no evidence of any other alien travelers, so to speak, then how did we get here? You know? And where do we come from? And are we really an element of the earth atmosphere and environment? I mean, there are different theories that point that we came from someplace else. There's an internal spiritual type theory in the Bible you might speak of, where our souls, that energy of our souls, when we're born, is a soul that enters our bodies, and without it, we are primitive. And it stays with us till we die, and then it goes back to heaven. Well, if it goes back to heaven and it's going out somewhere out in the galaxy, in space, preferably to a different planet or a different galaxy. It doesn't have the weight of the carnal body. The body is left behind, but that energy what that takes form of a human being, uh, at the end, goes back where it came from. And it's a consistent activity. Everybody on earth has a soul. I read that someplace. Um, and so alien technology and physics comes in all phases. Is Are we the travelers? I think we are the travelers. I can't prove it. You know, some science says, well, we came from a Pacific area in the ocean. That was our birth area. You know, but it doesn't like physics and space and the universe doesn't explain everything in detail. The universe, we don't know exactly how it started or came to being, and neither we do about human beings. But could we have come from a greater civilization that brought us here? You know, and the bit about our souls is the intellect and technology of our intelligence. All right, wrote around 15 books explaining what I've come to tell you in this video. And it's a 24th century explanation of theoretical physics. Theoretical physics is a science that is mathematically shown to be true. Doesn't mean it's true. We have no real evidence. But we do have a future. And why everything directs ourselves to outer space and other galaxies and everything, whether it's scientific or it's the idea of about our existence, explain where we came from, or were we born here on Earth, in the ocean, and well, you know, kind of like know what I'm talking about. Anyways, if you're that scientific guy that's interested in advanced physics, this is the next topple from Erwin Hubble. Relativity, the expansion of the universe, he calls it the sphere, space expansion, and repulsive gravity, which is constant, but is changing. They say it's accelerating. Yeah, probably take millions of years to show that in any way. But I hope you like this video. Thank you very much.